Good morning. You're very welcome to this week's episode of the Signpost webinar series. My name is Cian Condon. I'm the coordinator of the Teagasc Connected program and also more recently of the Signpost webinar series. We're always delighted to get your input as well into the series. So if you have thoughts or comments on speakers or potential subjects, please let us know through the survey associated with the series, or you can drop an email directly to connected@teagasc.ie. I'm joined this morning by my colleague Mícheál Kelly. Mícheál will be helping out on questions towards the end. But our speaker this morning is Marie Merlo, and Marie is a PhD student based in Moorpark, and she'll be speaking on the impact of agricultural diversification on protein security in Ireland. And no better person than to introduce Marie than Marie herself. So I'll let you say a little bit just about what you'll be speaking about this morning, Marie.
Yeah, thank you very much. Thank you for having me as well. So I'll be talking about the U Protein project and my research as part of this project. So that was part of my PhD that I finished last year. And the idea was first to look at the sustainability of the protein sector in Ireland, how the sector is actually doing, not only economically and environmentally, but also from a nutrition perspective. And then to look at the impact of some policy, especially agricultural diversification policy, on this sustainability and on those sustainability performances.
That's brilliant. Thanks a million, Marie. So if you want to share your screen, and just while you're doing that, I'll remind everyone, as usual, we want to keep things as interactive as possible. So you'll see the Q&A function there at the bottom of your screen. And if you want to put any questions related to the presentation in the Q&A, and we'll have some time at the end to get Marie hopefully to answer them. Thanks a million, everyone. We'll talk to you in a few minutes. Thanks, Marie. You can go ahead.
Yeah, thanks very much. So yeah, the title of the presentation will be the impact of agricultural diversification on protein security in Ireland. As I said, this was part of my PhD research, and I'd like to thank my supervisors, Cathal Buckley, Thea Hennessy, and Seamus O'Mahony, who accompanied me throughout the 4 years of that PhD. So just in terms of outline, what I'll be talking about today, first an introduction and context. So why look into this topic? Why look into those research questions especially? And why is Ireland a great candidate when we look at those very important topic that I'll be talking about? Then a methodology, how is the research conducted, results, and then discussion and conclusion. And I'll be happy to take any questions. So okay, introduction and context. So why protein, why Ireland, and why the sustainability of the sector is a big question these days. So in terms of agriculture and environment, the food production system needs to sustainably meet the need of the world's growing population, but several planetary boundaries are already crossed, with agriculture pointed out as a major cause. So you can see here, this was taken from Campbell et al. And you can see that, for example, biosphere integrity, biochemical flows, and climate change are planetary boundaries that are either in high risk or increasing risk of being crossed. And the black dots represent the impact of agriculture on the degradation of those planetary boundaries. So there's a big question as to what is the impact of agriculture on environment and how to limit this impact. However, agriculture also contributes to crucial ecological processes as well as to food security. So, for example, agriculture contributes to biodiversity, to land use, to landscape development, and also to food security, with the main function of agriculture being to produce food. And the world's food demand is also expected to increase, mainly due to population growth. So we have this dual aspect of the agricultural sector and the interaction of agriculture and environment, whereas agriculture causes climate change and causes the crossing of several planetary boundaries, but it also contributes to positive environmental processes, ecological processes, and mostly contributes to food security through food production. The livestock sector is at the heart of this concern and of this complex picture. So enteric fermentation and manure management represent a large share of agricultural GHG emissions worldwide. However, protein is a crucial macronutrient composed of amino acids, 9 of which cannot be synthesized by the body and have to be assimilated through the diet. So again, the livestock sector inside the agricultural sector is representative of this issue of negative environmental impact, high GHG emission, but also big contribution to protein security, food security, and amino acids and protein are one of those macronutrients that cannot be synthesized by the body, so it has to be assimilated to the diet. So again, a very complex picture of positive and negative contributions. You can see here from the Lancet Commission, this was a report that came out in 2019 that was discussed a lot. So what they did in the Lancet report was to create a diet that was sustainable and healthy. So they created a diet that respected planetary boundaries, as I presented just now, met the criteria of the Paris Agreement, environmentally speaking, and also was able to meet dietary requirements of human beings. And what they did is compare this sustainable diet to what we currently eat by region and globally. And you can see that the food groups that are the most overconsumed are protein sources. So red meat, eggs, poultry, and dairy, so animal-based protein sources, are overconsumed in most regions in the world. However, plant-based protein, such as legumes or grains, are underconsumed in all regions in the world. So there's imbalance here in terms of where do we get our protein from and what is the environmental impact of the protein we get in our diet, with inequalities between region, of course, but there's a clear picture here being drawn. Here is a critic of the Lancet diet. So a study came out in 2023 where they criticized the diet that was created in the Lancet report, mostly because it was deficient in some micronutrient for certain section of the population, for example, pregnant women. So you can see that the food group that they criticized the most when it came to their presence in the Lancet diet was animal-based protein. They thought that beef, pork, chicken, and eggs should be consumed in higher quantity than what the diet originally advised. So an important thing here that needs to be pointed out is that it's an ongoing debate, and it's a debate that has several sides, and there's no real consensus. So it's important to get the fact, and it's important to understand what is going on and to get actual numbers to reach the targets we set ourselves in terms of environmental, economic, and nutritional sustainability of the agricultural sector. Now, where does Ireland fit in that picture? So the Irish agricultural sector is really reliant on livestock products. Grassland and pasture is one of the most abundant resource Ireland has, which translated into a big presence of the livestock sector in its agricultural sector. And this also gets reflected in the country's GHG emissions profile. So you can see here, agriculture represents about 38% of the total GHG emissions in Ireland, against about 12% in the European Union. And in the agricultural sector, livestock represents about more than 3/4 of the agricultural GHG emissions in Ireland, against a bit less than 2/3 for the EU. So there is a clear picture here again of the impact of agriculture on GHG emissions and the relative importance of agriculture and livestock in GHG emissions originating in Ireland. From that situation, there was a very ambitious target that was set up by the government, whereby agricultural GHG emissions have to reduce by 25% by 2030 compared to 2018 levels. So that's a very ambitious target. And to do that, or to reach that target, several policies are either being considered or implemented to contribute to reaching this. So several policies are getting considered, and projections derived from the FAPRI Ireland model show that agricultural activity is very sensitive to climate-related policy. And policies oriented towards agricultural diversification are of particular importance. So this table here was the assumptions in that table were taken from FAPRI, the FAPRI model assumption. You can hear more about the FAPRI on the marginal abatement cost curve document that was published by Teagasc in 2023. But basically, what the FAPRI model does is it creates assumption around the economic and policy landscape that the agricultural sector will evolve in the next decade, and derives levels of agricultural activity based on those economic and policy assumptions. So I selected two scenarios here. The first one is a business as usual scenario where there's a continuity in agricultural policy and economic variables remain kind of the same. So what the FAPRI model kind of projects is a decrease in beef and sheep livestock unit, but an increase in dairy cow livestock unit, And a second scenario then looks at a decrease in agricultural activity levels, mostly due to policies that are aimed at reducing GHG emissions, going through disincentive on beef production and a decrease in milk prices. So that's for the FAPRI model. That are some assumptions about agricultural diversification that could lead to a decrease in GHG emissions, contributing to reaching that 25% reduction target. And there's another policy piece that I focused on during this research, which was part of the Food Vision report, where they advised an increase in tillage area by 50,000 hectares to, again, promote this aspect of agricultural diversification, land use change, and contribution to lower GHG emission. So those projections kind of feed into this need in Ireland to decrease GHG emissions coming from agriculture, mostly operating through a decrease in protein sources coming from beef and sheep meat, and an increase in tillage area, legumes and cereals, so plant-based protein sources. So what is the current situation in Ireland when it comes to protein and where we get our protein from and what are the proteins produced and where do they go? So the Irish agricultural sector is an important contributor to national and global food and protein security. So what is produced in Ireland doesn't necessarily stay in Ireland. Ireland is a very export-oriented country when it comes to its agricultural sector. So here you can see Ireland is the fourth larger exporter of mutton and goat meat, and the 10th larger exporter of bovine meat in the world, despite only being the 26th largest economy. So Ireland is a big producer of protein, mostly animal-based protein, livestock-based products, and it exports those products. So it's not only an important sector at the national level for the national economy, but it also has a strategic importance globally. And meat and dairy products also have a large role in Irish diets still. So about 68% of protein supply in Ireland come from animal sources against only 19% from cereals and 14% from other sources. This is slightly more than what we can observe in the European Union. So diversification will have an impact on climate. The aim of diversification policies and agricultural diversification is mostly to reduce GHG emission, but it will also have an impact on protein security, not only nationally, but also globally. So it's important here to notice that we're trying to draw a picture that is holistic. So we are not only addressing an environmental concern, but also a nutritional concern. So we're trying to get a clear picture of what is happening and what could happen based on several policy decisions. So the research questions are, what is the current sustainability performance of the Irish protein sector? Where are we at now? What are we actually starting from? What is the net contribution of the Irish agriculture to protein security? And how would this contribution be impacted by diversification measures and land use change policies? So how do we answer those questions? The main data set used was the Teagasc National Farm Survey. It's a survey that is circulated around 900 farms and represents the entire Irish agricultural sector. The sustainability dimensions we consider are economic, environmental, and nutrition sustainability. So again, not only one dimension, but we try to integrate as many dimensions as we can in one research and in one set of results to really get a clear picture of what is happening and what could happen. In terms of economic performances, gross margin and net margin were used, expressed per hectare, both of them. Then GHG emissions calculated according to the IPCC methodology to be consistent with what the Irish Environmental Protection Agency is doing and what they recommend to do. So when they set this target of 25% reduction in GHG emission, how are those GHG emissions calculated? It's using the IPCC methodology. So that's what we do as well, to be consistent. And GHG emissions are expressed per hectare and per 100 gram of gross and digestible protein to really get this idea of there is an environmental impact that differs between protein sources, but there's also protein being produced to a certain level. So we really try to get a comprehensive picture. And nutritionally speaking, we calculate gross protein production, so food output corrected for protein content expressed per hectare, and digestible protein production. So this is the gross protein production corrected for digestibility using the digestible indispensable amino acid score. So I'm just going to present this briefly, what it is, but basically, the one thing to know about protein is that not all protein sources are equal in terms of quality. So if you get 100 gram of protein from milk, or if you get 100 gram of protein from beans, they will not have the same quality. They will not be equivalent to each other. So the DIAS is a protein quality metric that evaluates how much essential amino acid is available to the body after the digestion process. So as I mentioned briefly earlier, amino acids are the building blocks of protein, and essential amino acids are amino acids that cannot be synthesized by the human body and have to be assimilated through the diet. So what the DIAS does is it tells us how many amino acids are left for the body to use after the digestion process is done. And depending on whether the amino acids come from animal-based protein or from plant-based protein, not the same amount will be left after the digestion process. So the DIAS is a percentage. And just to give you an idea, when you get protein from an animal-based sources, 100% of the amino acids from that protein source will be available to your body after the digestion. If you get protein from plant-based protein, about 50% on average, it ranged from about 40 to 60%, but on average, 50% of the amino acids you ingest through those plant-based protein will be available to your body after digestion. So that's an important thing to consider when we compare protein sources, especially plant-based versus animal-based protein, to integrate this quality component and not just the quantity of protein that is produced. And both gross and digestible protein production are expressed per hectare. Then how do we evaluate the contribution to protein security? So we evaluate the gross and net digestible protein production, the net contribution of Irish products to protein security nationally and globally. So we subtract first human edible input for human edible output for each farm in terms of gross and digestible protein. So we do what I presented in the slide before, calculate the amount of protein that comes both from the output and from the input, what is going into and out of the farm. We allocate the human edible net output, so again, output minus input, net output of farms to the nutritional requirement of a representative individual to compute how many people can be fed by farm and year. This representative individual has characteristics that were taken from the HAC recommendations. We aggregate those values using current aggregate livestock unit and area under tillage to evaluate the total contribution to protein security. So namely, how many people can have their protein requirement met by Irish agricultural products and the Irish agricultural sector. And then we use the results per livestock unit to evaluate the impact of a livestock unit reduction and land use change following the implementation of climate mitigation measures, namely agricultural diversification policies. This is a recap of the table I've shown before about the FAPRI assumption and the tillage group from the Food Vision report. So we applied those changes in land use and in livestock unit as part of agricultural diversification measure to the result we find to see what would happen if those policies were actually implemented, what would happen not only to protein security, but also to farm level economics variables. So the results, I'll start with the baseline results. So what is the current sustainability performance of the Irish protein sector. So the first set of results is economic and environmental sustainability performance. So here you can see the gross and net margin per hectare of 5 products: beef meat, milk, sheep meat, cereals, and legumes. And you can see their environmental performance in terms of GHG emission per hectare and per 100 gram of gross protein and digestible protein. So the first thing to notice is that, economically speaking, milk is the most efficient product. It has a much higher gross and net margin per hectare compared to all the other products we considered. And it is followed by cereals and legumes. So plant-based protein have a relatively good economic performance, but not as good as milk. Then, environmentally speaking, we have a much larger level of GHG emission per hectare for milk. So that's the reverse of the story. The milk performs very well in terms of economic variable, but they are responsible of the majority of GHG emissions per hectare compared to other products, followed by beef meat and sheep meat, and then behind, so the lower GHG emissions per hectare are observed for cereals and legumes. Per 100 gram of gross and digestible protein, there's still big difference between animal-based and plant-based protein, but you can see here that the relative ranking changes. So if we look at GHG emissions per 100 gram of protein instead of per hectare, beef meat and sheep meat have the highest level, much higher than milk, and then cereals and legumes again perform much better in that aspect. You can see it here a bit more visually. So for dairy products, milk especially, we get this clear picture of high economic performance, high gross margin, high net margin per hectare, but also high GHG emission per hectare. For beef and sheep meat, it's a bit more complicated. They show poor economic performance, but also a relatively high level of GHG emissions. And then we get plant-based proteins, so cereals and legumes, low GHG emission level per hectare, but relatively good performance, economically speaking. Not as good as milk, but relatively good compared to sheep and beef meat. Then the baseline contribution to food security. So how much protein is actually produced from protein sources in Ireland? So the highest protein output, not corrected for digestibility. So gross protein output is just how much protein gets out of the farm. Net protein output is how much protein gets out of the farm minus how much protein was used in the production process in terms of input. And then net protein security translates that into how many individuals can have their requirement met by the production of protein on Irish farms. So cereals and legumes show a much higher level of protein production. Gross and net production are the same for plant-based protein because they don't use human edible protein input compared to livestock products. And then following cereals and legumes, we get milk that shows relatively good nutritional performance instead in terms of gross and net protein output and also net protein security. And then we have beef meat and sheep meat that perform not as good as milk and plant-based protein, if I can say it like that. So they show a lower level of protein output and conversely are able to meet the protein requirement of fewer people, fewer individuals. Now, if we apply this digestibility component, so the quality aspect, we include the quality aspect of protein in the results, we see that milk gets much closer and actually surpasses cereals in terms of protein production, protein output, and protein security. So the reason again here is because animal-based protein have higher dias, a higher digestibility component than plant-based protein. So that shows why it's important to consider both quantity and quality of protein when we compare sources, especially when we compare animal and plant-based protein sources, because the results can change depending on how we consider those two aspects. So milk now performs better, and the results are the same for animal-based protein, whether we apply this digestibility component or not, because 100% again of the amino acids in the protein can be used by your body after digestion, whereas it's about 50% for plant-based protein. So if we apply this digestibility component, milk production comes much closer to plant-based protein production, and we still have beef meat and sheep meat lagging relatively behind. And if we aggregate those values to the aggregate agricultural sector, we estimate that land-based production systems are able to meet the protein requirements of 20 million individuals, 35 if digestibility is accounted for. So the Irish agricultural sector is able to meet the protein requirement of more than 4 times its national population and about 6 times if digestibility is accounted for. So again, that stresses the fact that policy decisions with an aim at reducing GHG emission will also have an impact on protein security and food production, which is the primary aspect of agriculture, is food production. So what happens if we apply those land use changes and livestock unit variation to the agricultural sector? So in terms of farm economics, the business as usual scenario, so everything continues as it is in terms of policy landscape. We get a slight reduction in beef and sheep livestock unit, but a large reduction in milk livestock unit. What we observe is a slight decrease in gross margin because the reduction in beef and sheep livestock unit will not be compensated by the increase in dairy livestock units. So the decrease in beef and sheep meat production will not be compensated fully by milk production in terms of gross margin. However, because beef and sheep meat net margin, it lags so much behind that of milk, we actually observe an increase in aggregated net margin because this time milk production, the increase in milk production is enough to compensate the decrease in beef meat and sheep meat. With the climate policy scenario, we observe a decrease both in gross margin and net margin because the increase in milk, cereal, and legume production will not be enough to compensate beef meat and sheep meat production decrease, both in terms of gross and net margin. Now, in terms of protein security, the first business as usual scenario, we observe an increase both in protein output and protein security because because the increase in milk production is enough to compensate the decrease in sheep and beef meat production. So milk production is so efficient in terms of protein production that it is enough to compensate for the decrease in beef meat and sheep meat production, both in terms of gross protein output and when we apply the digestibility component to the protein output. However, for the climate policy implementation scenario, this is not as clear. So we get an increase in net protein output and protein security. This is without applying the digestibility component because the increase in milk, cereal, and legume production is enough to compensate beef meat and sheep meat. However, we observe a decrease in digestible protein security and net digestible protein output. Again, shows the importance of including this digestible or quality component when we talk about protein, because the results could actually change. So here we observe a decrease in digestible protein security and net digestible protein output, because what happens in the first instance, so the increase in milk, cereal, and legume production compensating for sheep meat and beef meat doesn't work when we apply the digestibility component, because effectively cereal and legume protein are replacing beef and sheep meat protein. And as I've said before, the quality is not the same. So the increase is enough to compensate the protein loss in gross term, but when we apply the digestibility component, it's not enough anymore. So we observe a decrease in digestible protein security and digestible protein output. So now to kind of wrap it up, a bit of discussion points. Measuring sustainability holistically is crucial when evaluating the agricultural sector and corresponding policies. It's not enough to consider only one sustainable metric or sustainability pillar. You have to really get a holistic picture of what is happening. The need to associate several sustainability dimensions holistically when evaluating agricultural policy has been documented, and results show that livestock reductions and substitution between dairy and beef livestock, as well as land use changes, could increase protein security and protein output if tillage area is increased. However, net digestible protein output and digestible protein security could and would decrease. So including protein quality and digestibility in our evaluation of protein production is essential. So finally, the Irish agricultural sector is at the center of complex issues, a negative environmental impact, but also a contribution to food and protein production and protein security, especially in Ireland. Ireland has ambitious environmental targets when it comes to GHG emissions, and environmental climate policies are designed to reach this target. However, those policies need to be evaluated holistically, and policy impact assessments and evaluation should consider impacts ranging from environmental, but also to economic and nutritional aspects. So just to finish, I'd like to acknowledge that this work, my PhD work, was part of the U-Protein project funded by DAFM. I would also like to thank my supervisors, Dr. Cathal Buckley from Teagasc and Professor Thea Hennessy and Seamus O'Mahony from University College Cork. And 4 papers got out of my PhD were published. So I presented here the results of the first and the third one, but the second and fourth one are also related to that topic if you'd like to have a look. So that's it for me. Thank you very much, and I'd be happy to take questions.
Thanks very much, Marie. If you want to stop sharing there, please.
Yep.
So yeah, look, plenty of questions coming in, and we'd appreciate if any of you have any thoughts or have any questions on what Marie was talking about, please put them in the Q&A function. Just Marie, the legume production, you know, it's I'd say a lot of people around the country that mightn't be that familiar with it because it's growing in certain areas and that. But there are certain incentives there. Have you any thoughts on the incentivization of production of legumes? Because I know there are some there at the moment, but just, you know, the figures were generally positive around legume production. I'm just wondering if you have any thoughts about incentivization of legume production.
Yeah, so there's the protein aid scheme that grants farmers some subsidies if they produce at least a mix of 50% legume, 50% cereals, or the incentive is higher if they produce 100% legumes in some parcels of their farm. It's a step for, so it's positive steps towards promoting legume production in Ireland, which is very low. If you look at the number of observations we got for example, milk of beef production compared to legume production, the difference is massive. So this is a good start. However, there are other non-financial or not directly financial barriers to legume production in Ireland that also need to be addressed. For example, legume production is way more volatile than milk or beef production. It's way more subject to environmental or climate change. So you are more susceptible to lose your legume production if there's a drought or if there's a flood compared to if you're producing milk or beef. And there's also, legumes are subject to pests and diseases more than cereals. So that's also a barrier for farmers. And they're also answer to different management requirements. So this is also a matter of telling farmer what is the risk, what is the reward, and information, I guess, is key outside of the obvious financial support they get out of the protein aid.
Sure. Thanks very much. That's a very comprehensive answer. Mícheál, we'll go to you. Have any questions there, please?
Marie, there was comment here. I suppose it's to do with policy. It's saying that we have a large number of farmers, we'll say, in the ANC scheme, and there's a requirement within that scheme that they have to maintain livestock on the farm for 7 months. Would you see reducing this retention period as a benefit in terms of reducing greenhouse gases?
Yeah, I mean, that could be an option. So that's, I guess, one of the main issue when we talk about the agricultural diversification policy is that there are several other policy factors that come clashing. if that makes sense. So there's an incentive to reduce livestock unit on one part as part of this agricultural diversification measure, but then there's this rule, as you just mentioned, to maintain livestock on part of your farm for a certain number of years. There's also the nitrogen directive, for example, that will influence the livestock stocking rate. So the interaction between policy and making sure that the policy landscape is coherent and also understandable and makes sense to farmer is important. What we try and emphasize is not like farmers should change entirely their production system. It's more like where soil is favorable to tillage production and where legumes could be produced on part of your farm, maybe that would be more of an option. So not change your entire production system, keep your livestock, but maybe introduce legumes in your current management system, if that makes sense.
Yeah, of course. And there's actually a question here that ties into this. Is our historical mixed enterprise model the solution? So where farmers would have livestock and tillage on the farm in the past is a reversion to this model. Would that be a possible solution?
I mean, it could be if soil allows, of course, because I know soil quality is also a very limiting factor especially when we talk about legume production. Cereals a bit less, but tillage in general, soil quality and soil characteristics are a big factor. But if it's possible, given the biophysical characteristics of your farm, then I think that would be a step forward.
Okay. And yeah, the one question here on the analysis, are pig and poultry protein included in the analysis?
No, so we focused on land-based systems, mostly because the National Farm Survey doesn't collect data on pigs and poultry. So they're not included in our analysis, only land-based systems, so cattle, dairy, sheep, and tillage. We are trying to get some data with other departments to kind of maybe extend that analysis, but so far it has not been done.
Yeah. And a question here, I suppose, it's back to policy again. Could you please shed some light on what specific policy measures your research directly communicates with, and what policy actions would you suggest based on your research?
So the scenarios used for the research were a mix of projections and assumptions from the MAC document with the food vision report and especially the tillage group section of the food vision report. So the agricultural diversification measure is part of the set of measures that is looked at in the MAC document, Marginal Abatement Cost Curve document that Teagasc published in 2023. And we use the underlying assumption from that measure to develop our scenarios. So the agricultural diversification measure is not that explicit in policy documents. So we used the FAPRI model assumptions to kind of put numbers on what was happening. And then the food vision report, the tillage group advised an increase in tillage area by 50,000 hectare. And we allocated those 50,000 hectare following the protein aid scheme that was mentioned earlier. So 50% increase in cereal area, 50% increase in legume area. So 25,000 hectares increase for each. So that's the policy assumptions we looked at.
Okay.
Go ahead, Jen.
No, go ahead.
And just wondering there, the climate policy scenario, the figures were very specific on reductions or increases, and that is, how did you come up with that particular scenario?
The FAPRI assumptions. So the FAPRI model has 3 scenarios. We focused on 2 because the third one was not going to achieve the 25% reduction in GHG emissions anyway. So we used the first 2. The first one is a business as usual scenario. So it kind of assumes a continuity in what is happening currently. So inclination towards reduction in GHG emissions, but a continuity in policies going that way and a continuity in the economic interactions we see in the agricultural sector. So milk prices remaining at a normal to high level, milk production being more economically efficient than beef and sheep production, driving an increase in dairy cows numbers and a decrease in sheep and cattle livestock unit numbers. And then the second scenario is a more intensive climate policy landscape with a disincentive to produce beef. So not only follow the natural decrease in cattle livestock unit induced by the relatively poor economic performance of the sector, but actively developing disincentives to that production, and also assuming relatively lower milk prices, which leads to that still increase in dairy cows, but not as much as if we assume a business as usual scenario. So these numbers were taken from the FAPRI assumptions.
Lovely, thanks very much. Mícheál?
Yeah, there's a question and a comment here. Very interesting presentation, and thank you. Have you considered including into the equation the fact that a good percentage of the population is intolerant to milk and that they rely on plant-based alternatives?
We didn't really go to too much detail in terms of consumption. So the analysis is very much at farm gate and the production side of the supply chain. So the primary production farm gate agricultural sector. We apply this number to to calculate the contribution to protein security, we take the baseline assumption from the HAC in terms of average weight, average protein requirement of a person per day. We didn't go into too much specifics in terms of intolerance, but that would be a good point to investigate going into the consumption side of things, and also acceptability of whatever changes we try to emphasize or promote, because I know some people would not really agree with not eating their steak anymore and go to like a plant-based steak, whereas some people might be gluten intolerant, so maybe some cereals might be not suitable for their diet. So going into that consumption aspect would be an interesting point as well.
Yeah, and there's two related questions here, I suppose. One of them is any correlation between land type and efficiency factors, as you cannot grow some proteins on some lands. And there's another one here related with dairy and tillage coming out favorable regarding protein production and economics. Unfortunately, land types in large parts of the West does not suit either. What do you suggest to replace beef or sheep enterprises, keeping biodiversity in mind, given large parts of the West have very little stock?
Yeah, so regarding the first question, yes, there is a difference. So if you look at a map of grassland versus cropland repartition in Ireland, and if you look at a map of soil quality in Ireland, they very much overlap. So you get the wide range of application on soils, good soil quality type, mostly in the east. Conversely, you get most of the cropland in the east, and you get the relatively poor soil quality in the west. Conversely, large part of grassland in the west. So there is a difference in not only performance, but also just the the face of the sector, really. So in a large majority of farms in the West that are currently producing sheep or cattle, you wouldn't be able to grow tillage anyway. So that's also not like, again, even if you have a livestock farm in the East, I'm not really saying like change it all, but maybe if farmers are more informed about the management practices, about the characteristics of legume production and cereal production, maybe this would help to increase tillage area, not change entirely the face of the sector, because Ireland is good at growing livestock and growing grass, and pastures are excellent in Ireland, which kind of sustain this economically advantageous livestock system, pasture-based system. But maybe going more into like the benefits of tillage production, legume production, even for example, if you have a tillage farm, but you're only producing cereals, introducing legumes into your crop rotation could actually have economic, environmental, and nutritional benefits. So that was another aspect of my research that I didn't present here for sake of time, but even going into existing tillage farmers and trying to introduce legumes as part of their current management habits would also be an option, not only like going to a livestock producer who has been producing livestock for generation and just tell him to change entirely their habits, but going into what already exists, what is already working pretty well, and try and make it work even better could also be a viable option.
Yeah. And there was a question here. How much of the legume production in Ireland goes to animal fodder as opposed to human consumption?
The majority.
Majority.
I don't have the number in mind anymore, but
Yeah.
that was a main point as well of my thesis was a large majority. If I was going to tell you more than 3/4, I don't think I'd be too far off. It's the same for cereals. So there is also this issue in Ireland that cereals are produced mostly for animal feed, which means the quality of the cereal itself is not the same as if it would be produced for primarily human consumption. So the cereal would need to be processed into flour or further ingredients to be consumable by humans. It's a bit less so for legumes, but there's also you can't really just harvest it and eat it, whereas milk, you just milk a cow and you can basically consume it right away. So this aspect is also important. As I said, we stopped the analysis at the farm gate, so we didn't really go after that, but there would be a need to change the variety of crops produced in Ireland if we were to redirect the production towards human consumption instead of animal feed. Also, an important aspect is that, and that is actually going in favor of Ireland, I would say, is that cattle, dairy, and sheep livestock units mostly consume grass. So that's also that would be an interesting point into including poultry and eggs or poultry and pig systems as well, is because their feed ration is majority human edible, whereas the livestock that Ireland is specialized in, a majority of their diet is composed of grass. So there could be here an opportunity to redirect part of the tillage production in Ireland towards human consumption, playing on the fact that grass does a really good job at meeting the requirements of dairy cows and sheep and cattle.
Yeah. There's something, it's kind of a follow on there. I suppose from mentioning the amount of legumes and cereals that go back into the animal diet. It seems the research allows for the percentage of livestock feed from human edible protein. Does the analysis examine the alternative scenario where the amount of land and fertilizer used for livestock feed would be used to produce human edible protein instead?
So it is, we kind of assume that if you produce crops in Ireland, they could be redirected. So that's an underlying assumption that might be a bit too general, but now, when you're conducting research, you have to kind of stop as to how deep you get into your assumptions, because otherwise you get a bit lost in the rabbit hole. But we kind of assume that if you're producing crop in Ireland, it can be used for human consumption. So yeah, in terms of land usage, we assume this is possible to begin with. I don't know if that answers the question or not, but yeah, it's more of an assumption. That's something we actively look at in the research.
Okay, and I suppose on your presentation there, are there any limitations of the amino acid score? Does it account for all the dietary diversity or complementary consumption patterns?
Yes, so that's an important thing about plant-based protein versus animal-based protein. So what the Dias does, I'm gonna try and be as clear as I can with that because I'm not a nutritionist, but I had to read a lot about it for my research. So there are 9 essential amino acids that you cannot synthesize that you need to get through the diet. So what the Dias does is it looks at those 9 individual amino acids, look at what your body needs, and look at what the protein source we consider brings you after digestion. So let's say that, for example, legumes, they're deficient in lysine amino acid. They take that, which is the amino acid they're the most deficient is, lysine, and they look at what is left of lysine from the protein you're consuming after digestion. So about 40% of the lysine you ingest through beans will be usable by your body. Whereas for animal-based protein, they have enough of all the 9 amino acids to meet your requirement, and you don't lose any throughout digestion. So that's an important part of animal versus plant-based protein. And actually that question is answered in my second paper, which I didn't present here, but is available. So we do look at crop rotations on farm, cereals plus legumes, and we kind of do this based on this point that if you only eat legumes, your protein or amino acid requirement won't be met. If you only eat cereals, they won't be met either. But if you combine them, they can be met provided you get the right ratio. So that's something we look at in terms of nutritional benefit of crop rotation and associated cereal and legumes. If you associate both in the correct quantity, you could get all the amino acids you need to function as a human body. Whereas it's a bit less complicated for animal-based protein because you just need one source, but cereals and legumes are complementary in the sense that one is deficit in one amino acid that the other has in abundance and vice versa. So this complementarity is important. And yeah, for dietary perspective, it's an opportunity provided that as a consumer, you know, this is existing and happening.
Okay. Yeah, there's another question here. Has the CO2 used in photosynthesis to produce animal feed been taken into account in your research?
Not in the IPCC methodology. So the IPCC methodology is more based on activity level. So you get input and output from the farm, and you derive GHG emissions from those input and output. So you get, for example, GHG emissions related to fertilizers, to enteric fermentation, manure management. Sorry. And you are really basing your calculations on those activity data. So for example, carbon sequestration wouldn't be included, or I don't think photosynthesis is included either. We got a lot of questions about that methodology, but the main rationale behind using it is to remain consistent with the Irish Environmental Protection Agency. So because the main point of this research was, or one of the big point of this research was to evaluate policy and to kind of go into this 25% reduction target. How do we get there? What does it mean for other sustainability components of the agricultural sector? And all of those considerations are based on IPCC calculations performed by the EPA. So we stuck to the IPCC methodology for this consistency aim.
Yeah. Thanks.
Marie, I'm interested. Obviously, we had questions and comments there about geographic location, climate, soil type, and that. Were there any other barriers, do you think, became apparent to you during your research for people to, consider the growing of legumes or particular cereal crops?
Finding a market for farmers would be a barrier that is discussed in the literature as well. So if, for example, like milk processing facility or meat processing facility exist in Ireland, they're present and farmers have those connections already. They have the supermarket they're selling to, they have the processing company they're doing business with. So that is an established supply chain. Whereas for legumes particularly, and also cereals to a lesser extent, because historically they have been used for animal feed, there's no real processing facilities in Ireland. There's no real the supply chain is less established than for animal products. So for a farmer, that might be a bit complicated to produce something they're not sure they're going to be able to sell, or they don't even know where to sell it afterwards. Sure. So that's a problem. And also, this view of volatility in terms of yield and pests and diseases compared to either regular crops or, to another extent, livestock products.
Sure, lovely. Thank you.
There was a comment and a question here in one. I presume it's to do with say meat products and their digestible protein security. Why are we not shouting this from high to all markets and use it for marketing our products? Every person, more importantly, parents feeding children, need to know this for making food decisions for their children. Have you any comments on that, Marie?
Well, this is still an evolving topic, if I can say it like that. So, as I showed you at the beginning, if you just take the Lancet Commission report that was published in 2019 and the critics of it that came in subsequent year with the main one published in 2023, this is still a source of debate. And I feel like, especially when it comes to food and when it comes to protein, there's also maybe an emotional component to it that means that you might know the numbers, but then, for example, you might know the numbers instead of in terms of digestibility or in terms of environmental performances, but there's still certain level of emotional decisions that come into play when we talk about protein, especially in Ireland, because livestock-based products are very important, not only economically or environmentally, but also to the culture of the country. So there's also this like maybe more or less rational component when it comes to food decisions. But that's also why this kind of research, I personally think, is important to kind of get the facts as well and to get informations that you might not have been aware of before or that might be like, yeah, hidden in a research paper somewhere. I think it's good to get the facts as well and get them clearly.
Yeah, and Marie, in your presentation there, you said that there was 38% of the greenhouse gas emissions are from agriculture in Ireland. 75% of this is coming from livestock, and we're looking at overall a 25% reduction by 2030. In your own opinion, are we going in the right direction? Are we on track?
There are projections on the EPA's website if you're interested. It will require a lot of adaptation and mitigation measures. It's also a big conclusion of the MAC document, again, if you want to read it, but this will require a lot of adaptation and mitigation measures implemented in the agricultural sector. So I I won't be as bold or brave as to tell you yes or no. It will be tough.
Yeah.
If I can get away with that, that would be great.
Yeah, no problem at all. Yeah, look, there was a couple of comments have come in there on your presentation. Brilliantly informative presentation. There's another comment here. Is it possible to have website links to Marie's research? They were up on your second slide there, so there's definitely people interested in your research matter.
Great. Well, they're all
Yeah,
published. The ones I presented and the one I didn't. So yeah,
yeah.
I'm very happy people are interested. That's very nice to hear.
That's great. Listen, thanks a million, Mícheál and Marie. We're getting close to finish time here, so I'll start to wrap things up. I'd like to thank Marie for her input and her insights this morning. Really interesting, and as Mícheál said, a lot of really, really positive comments there this morning. Thanks a million to Mícheál, of course, for his help. As always, Mícheál, thanks a million. And of course, just want to mention there's a full team behind this, though. There's a Signpost team putting the webinar together in the background each week, so thanks to them. Next week, we'll be joined by Nicola Warden. And Nicola is the Senior Biodiversity Technologist with CAFRE. And she'll be bringing us on their journey to increase biodiversity at the CAFRE Glenwherry farm, which is up in Antrim. So I'd just like to say thanks everyone for joining us. We'd really hope you could join us next week again. And thanks a million for your time. Take care and enjoy the weekend.